Occupied France, August 1943. At a remote Luftwaffe airfield, shortly after 400 hours, Oberleutnant Vera Schultz, Chief Technical Officer of Jagdgeschwader 26, received news that should have been a significant triumph. An American P-47 Thunderbolt had been forced down, its pilot captured, and the aircraft itself was recovered largely intact. This was intelligence gold. For months, German pilots had encountered this massive American fighter, reporting capabilities that seemed almost unbelievable. Now, German engineers would finally have an opportunity to scrutinize one up close. When Schultz first saw the P-47 on the tarmac, his initial reaction mirrored that of every pilot who had encountered it. It appeared grotesque, an obscenely corpulent and ungainly flying milk bottle. However, as he embarked on his methodical examination of the enemy machine, the engineer, who placed his faith in quantifiable data, was about to uncover a devastating truth. The P-47 was not grotesque. It was a harbinger, and its constituent parts served as a mathematical testament that Germany had already lost a conflict its leadership was oblivious to. Schultz was not a combat aviator, but an aeronautical engineer who had previously worked for Messerschmitt before the war. His role was to comprehend enemy aircraft, identify their vulnerabilities, and propose tactical countermeasures. Upon arriving at the airfield and seeing the P-47 for the first time, his initial impression was consistent with that of all German pilots. The aircraft was grotesque, excessively bulky, and awkward. The fuselage was enormous, designed around a colossal radial engine. The fully loaded aircraft tipped the scales at nearly 8 tons. For comparative purposes, Germany's primary fighter, the Focke-Wulf 190, weighed approximately 4 tons. German pilots had affectionately nicknamed it the Flying Barrel or Flying Milk Bottle. Gazing at it resting on the tarmac, Schultz understood the moniker. It seemed incapable of flight. But Schultz was a scientist. Outward appearance held no sway over him. He was concerned with performance. As he commenced his inspection, what he discovered would profoundly unsettle him. Schultz began with the core of the machine, the Pratt & Whitney R2800 double wasp engine. When his team removed the engine cowling, they stood in stunned silence for a considerable duration. The engine was immense, featuring 18 cylinders arranged in 2 rows of 9, forming a radial configuration that accounted for the P-47's substantial bulk. Yet, it was not merely its size that astonished Schultz. It was the superior craftsmanship, the meticulous precision, and the advanced engineering sophistication. Every component was manufactured to tolerances that German factories were struggling to consistently achieve. The cylinders were uniform and perfectly balanced. The crankshaft was a marvel of metallurgical achievement. Schultz retrieved his notepad and began to perform calculations. Based on its displacement and design, this engine was producing at least 2,000 horsepower, potentially more, considering the turbo supercharger system he observed integrated into the fuselage. In contrast, the BMW 8001 radial engine powering the Focke-Wulf 190 generated approximately 1,700 horsepower at its maximum output, pushing the limits of German engine technology. The Americans were mass-producing engines with 20 to 30% greater power, and doing so with apparent ease. The situation, however, grew progressively worse. Schultz meticulously inspected the engine's construction for any indications of cost-saving compromises, the kind of concessions German factories were increasingly compelled to make. Inferior materials, simplified manufacturing processes, anything to conserve resources. He found none. This engine was constructed using high-grade aluminum alloys, precision bearings, and components that exhibited no evidence of material scarcity or manufacturing shortcuts. It was built correctly, not expediently. One of Schultz's assistants, a mechanic with years of experience on German aircraft, pointed to the cylinders. "Herr Oberleutnant, look at this. Each cylinder is individually removable. If one is damaged, you can replace just that component without disassembling the entire engine." Schultz nodded slowly. It was an ingenious design, facilitating quicker repairs, minimizing downtime, and maximizing aircraft availability. German engines required extensive disassembly for major maintenance. This American design presupposed frequent and efficient maintenance procedures. However, another detail captured Schultz's attention, something that sent a chill of dread through him. The true secret to the P-47's performance lay not solely in its engine, but in its turbo-supercharger system. Schultz had encountered intelligence reports detailing this technology, but witnessing it firsthand was entirely different. A complex network of conduits snaked from the engine, descending through the fuselage to a turbine mounted at the aircraft's rear. This system utilized the engine's exhaust gases to spin a compressor at over 20,000 revolutions per minute, forcing compressed air back into the engine. The engineering involved was staggering. Exhaust gases had to be routed through conduits capable of withstanding extreme heat, and the turbine had to rotate at speeds that would shatter inferior bearings. The entire system demanded precise calibration to prevent engine damage. German engineers had experimented with turbo superchargers, but had never successfully deployed them. The technical challenges were too significant, the necessary materials too scarce, and the manufacturing processes too intricate. Yet, here it was, integrated into an American fighter being mass-produced. Not a prototype, not an experimental model, but a production aircraft, one of hundreds or thousands. Schultz performed the calculations. With this turbo supercharger, the P-47's engine could maintain full power at altitudes where German fighters were struggling for air. Above 25,000 feet, the Focke-Wulf 190 and Messerschmitt Bf 109 experienced significant performance degradation as their mechanical superchargers faltered in the rarefied atmosphere. The P-47, conversely, would be reaching its optimal performance. It was fast, powerful, and utterly dominant in the high-altitude domain where German fighters were required to operate to intercept bomber formations. His assistant posed the inevitable question: can we replicate this system? Oberleutnant Schultz shook his head. Not with our current manufacturing capacity. This system demands precision machining, high-grade steel alloys, and thousands of man-hours of skilled labor. We are already struggling to produce sufficient basic aircraft. He paused. Adding this level of complexity is beyond our capabilities. The realization was crushing. The Americans had not merely constructed a superior fighter, they had engineered an aircraft that embodied an industrial sophistication Germany could not rival. After examining the engine, Schultz turned his attention to the airframe itself, discovering equally disquieting facts. The P-47 had sustained considerable combat damage. Cannon fire had ripped through sections of the fuselage, and machine gun fire had riddled the wings. Yet, the aircraft had managed to return and execute a controlled landing. Schultz analyzed the damage patterns. Multiple 20-millimeter cannon impacts, the kind that would typically obliterate a German fighter, had been absorbed by the P-47 structure. Its heavy-gauge aluminum skin, robust internal framework, and redundant control systems all contributed to its exceptional durability. He consulted damage reports from Luftwaffe units. Time and again, pilots reported unleashing cannon fire on P-47s only to witness in disbelief as the American fighters continued their flight. The reason was apparent. The P-47 was built like a tank, whereas German fighters were optimized for weight savings and agility. The P-47 was engineered to endure punishment and remain airborne. The cockpit armor was extensive, with thick steel plates protecting the pilot from multiple angles. The windscreen was armored glass, considerably thicker than that found in German fighters. Most critically, the R2800 radial engine served as a formidable shield. Unlike the liquid-cooled inline engines of the Bf-109 and Focke-Wulf 190, the radial design lacked a vulnerable coolant system. Cylinders could be shot off the engine, and it would continue to operate. Schultz found documentation indicating that P-47s had returned to base with multiple cylinders destroyed, fuel tanks punctured, and control surfaces shot away. German fighters sustaining similar damage would have plummeted from the sky. One of his engineers remarked, "It's over-engineered. They've added weight for durability that could have been used for performance." Schultz concurred. "Yes, but they can't afford to. They possess engines powerful enough to carry the additional weight. We cannot. We must optimize for weight because we lack the engine power to compensate for it." This represented a fundamental divergence in design philosophy. Germany constructed aircraft at the very edge of technical possibility, extracting every ounce of performance from limited resources. America built aircraft with substantial safety margins, counteracting any inefficiencies with sheer power. And, brutally, the American approach proved more effective. Schultz then examined the P-47's armament. 8 Browning M250 caliber machine guns, 4 mounted in each wing. His heart sank as he calculated the implications. Each gun possessed approximately 400 rounds of ammunition, totaling 3,200 rounds. The combined rate of fire from all 8 guns exceeded 100 rounds per second. The firepower was devastating. A single-second burst would unleash 100 heavy projectiles onto a target. A 2-second burst, typical for a firing pass, would discharge 200 rounds. German fighters generally carried 2 or 4 machine guns, supplemented by 1 or 2 cannons. The total firepower was less, and ammunition was more restricted. A Bf-109 might carry 60 rounds for its cannon and 500 for its machine guns. Once expended, the pilot had to return to base. The P-47 pilot could fire almost continuously for 30 seconds. In practical terms, this translated to multiple sustained bursts across several engagements before exhausting their ammunition. However, it was not merely the quantity. Schultz examined the 50 caliber rounds themselves. They were heavy, high-velocity projectiles capable of penetrating armor and structural components with ease. He had read pilot reports describing the effect of P-47 fire as a wall of lead. Now he understood why. With 8 guns converging at a focal point, anything caught in that cone of fire would be shredded. German aircraft, with their lightweight construction and limited armor, would disintegrate under this level of firepower. A P-47 did not require pinpoint accuracy. It simply needed to bring the target generally into its sights and engage. Schultz made notations. Recommendation: avoid head-on engagements with P-47. Probability of surviving return fire is minimal. As Schultz compiled his technical report, a pattern emerged that extended beyond any single component. Every system on the P-47 spoke to an underlying industrial capacity that was simply staggering. The engine necessitated precision machining and high-grade alloys. The turbo supercharger demanded advanced metallurgy and manufacturing techniques. The airframe required vast quantities of aluminum. The armament relied on a functional ammunition production industry. Any single one of these components would strain German industry. The P-47 integrated all of them into a single aircraft and was being mass-produced. Schultz requested production data from intelligence sources. What he learned was soul-crushing. Republic Aviation was manufacturing P-47s at a seemingly impossible rate. By late 1943, they were producing over 500 aircraft per month, with plans to escalate to 600, 700, and even 800 per month by 1944. For comparison, German factories were struggling to produce a total of 300 to 400 single-engine fighters per month across all types, and German production was constantly hampered by Allied bombing raids. However, the numbers worsened. The R-2800 engine was not exclusive to the P-47. It powered multiple American aircraft. Total production of R-2800 engines would exceed 125,000 units during the war. Over 125,000 of these 2,000 horsepower engines. Germany's entire output of aircraft engines for all types throughout the entire war would approximate 250,000 units, the majority of which were significantly less powerful. The Americans were producing more of a single advanced engine type than Germany could produce in total engines. The disparity was incomprehensible. Schultz sat at his desk, staring at the figures. He recalculated, convinced he must have made an error, but the numbers remained unchanged. American aircraft production for 1943 was projected to surpass 85,000 aircraft, while German production would be around 25,000, a ratio exceeding 3-to-1. Yet, the situation was more dire as American aircraft were, on average, heavier and more complex. A single B-17 bomber required more aluminum and man-hours than 3 Messerschmitt Bf-109 fighters. The Americans were producing thousands of B-17s. The material disparity was overwhelming. America was engaged in a global conflict, supplying thousands of aircraft and tanks to the Soviets, equipping British forces, and still outproducing Germany in every category. Schultz's final report was slated for presentation to High Command in Berlin. As he compiled his findings, he knew he was documenting something dangerous. The report detailed the P-47's technical superiority in numerous aspects. It acknowledged Germany's inability to match the industrial capacity required to produce equivalent systems, and concluded with a statement that would be perceived as defeatist. His summary read, "The P-47 Thunderbolt represents a level of industrial and technological sophistication that surpasses Germany's current capabilities. Its widespread deployment suggests American production capacity far exceeds previous intelligence estimates. Recommendation: tactical adjustments to minimize engagement with the P-47 at high altitudes. Strategic assessment indicates continued attrition against numerically and technically superior enemy aircraft will result in unsustainable losses." In simpler terms, he was stating, We cannot overcome this, and if we persist in fighting this way, we will be annihilated. Schultz's commanding officer read the report and regarded him with a mixture of respect and concern. You realize this will not be well received in Berlin. They do not wish to hear that American aircraft are superior. Should I alter the findings? Schultz inquired, already aware of the answer. No, the report is accurate, but prepare yourself. The leadership does not respond favorably to uncomfortable truths. The report was forwarded up the chain of command. Schultz never received an official reply, but he learned through informal channels that it had been dismissed as overly pessimistic. One staff officer reportedly commented, "This engineer has been demoralized by enemy propaganda. The P-47 is crude American engineering, inferior to our designs." Schultz was not surprised. He had witnessed this pattern before. Intelligence that contradicted Nazi ideology was rejected regardless of its factual accuracy. However, for Schultz personally, the examination of the P-47 had been a revelation, not just about the aircraft, but about the war itself. In the months following his report, Schultz observed his predictions materialize. P-47s appeared in increasing numbers over Europe, and German fighter losses mounted. Experienced pilots were shot down and not replaced. The tactical recommendations he had made, avoiding high-altitude engagements and employing hit-and-run tactics, were slowly adopted, but by then it was too late. The Americans had achieved air superiority through sheer weight of numbers and technical advantage. Schultz examined other captured American aircraft. Each one conveyed the same narrative: superior materials, sophisticated systems, evidence of an industrial base operating at a scale Germany could not replicate. He observed a captured C-47 transport plane, one of over 10,000 that would be produced. Germany's entire transport fleet comprised a few hundred aircraft, mostly obsolete designs. He examined a P-51 Mustang, which combined the range of the P-47 with even superior performance. Its engine was a Packard-built Rolls-Royce Merlin, manufactured under license in America, with thousands of them produced. Every aircraft he examined reinforced the same conclusion. Germany was losing an industrial war to an adversary possessing overwhelming material superiority. What troubled Schultz profoundly was that this information was accessible. The intelligence existed. German agents reported on American production and captured equipment attested to its quality, yet the leadership refused to accept it. Or, more accurately, they accepted it, but maintained that German willpower and superior tactics could overcome material disadvantage. Schultz had been trained as an engineer. He believed in numbers, in mathematics, in physical reality, and the physical reality was undeniable. Germany was being overwhelmed by an avalanche of American steel. After the war, when production figures were declassified, Schultz's estimates proved conservative. He had, in fact, underestimated American capacity. Total American aircraft production from 1940 to 1945 exceeded 300,000 aircraft. German production during the same period was approximately 94,000. The United States alone produced over 15,600 P-47 Thunderbolts, more than Germany produced of the Bf-109 and Focke-Wulf 190 combined. The R-2800 engine that Schultz had examined with such awe in 1943 saw over 125,000 units built, not only by Pratt and Whitney, but also by Ford, Chevrolet, and other automotive companies converted to war production. The industrial mobilization that yielded these numbers was unprecedented in human history. American factories that had previously manufactured automobiles were retooled to produce aircraft engines. Shipyards that built freighters were constructing aircraft carriers, and it was not merely quantity, the quality remained high. Late-war American aircraft exhibited no signs of declining standards, no shortcuts, and no compromises necessitated by material shortages. German aircraft, in contrast, displayed increasing evidence of resource constraints, inferior materials, simplified construction, and quality control issues as experienced workers were drafted and replaced by forced labor. Schultz survived the war and was interrogated by American technical intelligence officers. They expressed particular interest in his 1943 report on the P-47. Did you truly conclude from examining a single aircraft that Germany would lose the war? An American officer inquired. Schultz paused for a moment before replying. I concluded that Germany could not win an industrial war against America. The P-47 was evidence of a production capacity we could not match. Every component, every system, required resources and manufacturing capability that exceeded Germany's total capacity. But you were just one engineer, the officer pressed. Surely others reached the same conclusion. Many did, Schultz acknowledged, but in the Third Reich, stating inconvenient truths was perilous. It was better to remain silent than to be accused of defeatism. The American officer nodded. We found your report in captured German files. It was marked filed, no action required. Did that surprise you? Schultz laughed bitterly. No, I expected it. The Nazi leadership did not desire intelligence. They sought validation of their preconceived notions. When reality contradicted ideology, reality was dismissed. The story of Vera Schultz and the captured P-47 serves as a microcosm of Germany's strategic failure. A trained engineer examined enemy equipment, reached an accurate conclusion regarding Germany's industrial disadvantage, and was disregarded. His experience paralleled that of Admiral Canaris, who warned of American industrial capacity, Albert Speer, who understood Germany's inability to win a production war, Adolf Galland, who recognized the P-47's tactical superiority, and SS Oberstgruppenführer Sepp Dietrich, who knew the Ardennes offensive would fail due to a lack of fuel. In every instance, competent individuals perceived the truth, but were ensnared within a system where truth was subservient to ideology. They provided accurate assessments and were dismissed as defeatists or pessimists. The Nazi regime was founded on the premise that German racial and cultural superiority would surmount any material obstacles, that willpower and determination were more significant than industrial capacity, and that ideology could triumph over mathematics. They were mistaken, and men like Schultz knew they were mistaken from the moment they examined the evidence. However, knowing the truth and possessing the ability to act upon it are distinct matters. Schultz's report on the P-47 should have been a wake-up call. This event ought to have prompted a profound re-evaluation of Germany's standing on the global stage. However, it was simply put aside and neglected. The P-47 later emerged as one of the most manufactured fighter planes of the Second World War, with an output exceeding 15,600 units. These aircraft were responsible for downing thousands of enemy planes and played a crucial role in the Allied invasion of Europe. Their contribution was instrumental in securing the air dominance that rendered Germany's eventual downfall a certainty. And the genesis of this pivotal shift can be traced back to a single engineer inspecting a single enemy aircraft, leading him to the stark realization that his country had already conceded defeat in a conflict they were unaware they were engaged in. This was not a contest of military personnel or battle strategies, but rather a struggle of production lines and raw materials. A war in which the nation possessing greater quantities of oil, aluminum, and steel, along with superior manufacturing capabilities, was destined to triumph. The United States possessed these assets in plentiful supply, while Germany lacked them entirely.